Okay, so just bringing your attention to our updated Gantt chart here. By the end of today, the end of second week, my recommendation is that you probably have those first two assignments, or the first two exercises in assignment 1 done completely. That'll give you the entire next week to do that third one, which is the bulk of the work. It requires searching and sorting, which we'll be covering here shortly. But I recommend that you leave all of next week to that third program. It also requires some file I/O, which we're going to start today. And you can hand it in piecemeal if you want. You can hand in the first one, the second one, and it will work, or it will grade and verify that everything works. Once you've got those out of your inbox, then you can go ahead and start working on that third one. But otherwise, before we continue with file I/O, I just wanted to bring your attention explicitly to what we've been doing implicitly this entire time, that style notes. All variables should be lower camel-cased in Java, right? That is the Java standard, period. You can get away with other styles, but that's not the Java way of doing it. And of course, variables should be nouns because they represent things, people, places, things. You should only pluralize a variable name when it represents a collection. Not number of students is one thing. X is one thing, right? Total is one thing. But if you have students, right, then only then, like a list of student objects or something, then and only then do you actually pluralize it. All methods should also be lower camel-cased, okay? And should be verbs. Get value or get some or something like that, right? All classes should be upper camel-cased and never pluralized. They also should be, of course, be nouns. We'll look into our own classes here shortly, but otherwise make sure that you're at least following this upper camel-casing convention. And also use proper Java whitespace. First of all, you should get in the habit of writing correct code to begin with, but remember, if you're ever at a loss for what the correct code looks like, Shift Command F will reformat everything for you in the Java standard. Okay? So let's go ahead and continue with file I/O. You're going to have to, at some point, work with files, right? Because on a computer system, everything is a file. The source code that you're working with, that's stored in a plain text file. The images that you're manipulating, those are stored in binary files. The socket that you open to communicate to another computer, you are to send data to another computer, you are writing to that socket, which is a file. They are, on the other end, they're reading from that socket, and they're reading from a file that's a socket. Everything is a file. A file is a file, a directory is a file, and a program is also a file, because it's just something stored in memory, right? We're going to look only at plain text files, because if you do need to do binary files, like opening up an image and changing it to a sepia tone or something like that, use a library, right? It is too much of a headache to read in byte for byte and make sure that you're doing this for a GIF, and then you're doing it completely different for a PNG, and you're doing it completely different for a JPEG, right? Use a library, right? Don't get into that headache. Instead, we're going to focus on plain text files. I'm going to show you the easiest way of doing things. So first of all, let's focus on file output, right? So same basic steps in all three of these. You need to open the file, right? Write to the file, then close the file, right? So 3 steps there. Open the file, write to the file, close to the file. Now, if you were actually reading from a file, what would you do? You would open the file, read from the file, and then you'd close the file. I am going to emphasize this last one, right? Because failure to close your resources may lead to data corruption. If you open up a file and then you process it, and you fail to close it, it might not actually get out to disk, right? Only part of it might, or there's going to be a complete failure of the data, right? So let's look at file output. To do that, first of all, I need a file. So file F is equal to new file, and also I need a place to store it. So I'm going to come over here to my my project here, and I'm going to create a folder, right, to store all my data, and I'll call it simply just data. You don't have to put it in data. You can put it anywhere on disk. Good luck going and fishing for that file, right? I'm going to put everything into my data file within my project. If you don't put it within the data file, then it's probably relative to the project. And so you're going to start putting files up here at the top level, which you don't want to do, right? Because again, good luck fishing for it and finding it, right? But anyway, I'm going to put a new file called output, or my output.txt. There we go. Now that just represents the idea of a file. And also I need to import these. You'll see that everything in Java is going to be in the IO library, input output. Those come in from a C background. You include the stdio library, and you've got all these input output things. In Python, I think that it's included in the standard language, so you don't have to import anything. Don't quote me on that. But in any case, I've only ever created the idea of this file in this directory. There's the data directory, slash, and it is a forward slash, and then the name of the file. This is just going to be a plain text file. Okay? Now what I need to do is I need to open up that file for writing. Right? And to do that, I'm going to show you the simplest way of doing it using a print writer. A print writer is just simply going to print to the file, and I'll just call it PW because there's no better name for it. Is equal to new print writer, right? Spell it right. And it's going to be writing to this file that I just created, right? If I just do that, then what are you writing to, right? Maybe the standard output, but probably not. It's probably not even going to compile. All right, we'll come back. Let me import this. We're still going to have a compiler error, but I'll come back to why in a moment here. All right, I just want to move on and show you the code. Once you've got your print writer, guess what you can do? pw.println. Hello, this is one line. Println, does that look familiar? pw.print. This is a line without an end line. There we go. pw.print. Now I'll put the end line in, or end line in. How do I put an end line in? \n. Okay. pw.printf. Variables. Right? If you want to print variables, you can use the printf functionality. %d, %f. And I'll end the line there as well. And let's go ahead and go with, I don't know, a and b. I'll go ahead and declare those variables up here. Right? So int a is equal to 10, int, or say double, because it's a placeholder for %f is a floating point number, 3.5. There we go. All right, I'm going to print. Again, does this look familiar? Println, printf. What does that tell you about system.out? It's the same type of object. You're just not printing to a file. What are you printing to? To the standard output, which is a console. Guess what the console is? It's a file. Right? You're writing to the file that gets displayed to the user. It's just this different special type of file. Once I'm done, what should I do? What was that step 3 that I put in bold? Close it. So pw.close. Failure to close your resources may result in data corruption, so be careful. Now this is not going to be runnable yet because I have not had it compile. Let's go ahead and hover over this and see what the suggestion is, or see what the problem is. An unhandled exception type file not found exception. This is what's called a checked exception. And I am forced to surround this with a try and catch. Right? Let me move all of this stuff up because it did it like that. Okay? There. Now it will actually compile and it'll actually run. Before we run it though, let's understand what's going on here. All of this is potentially dangerous code. Because what could happen? You may not have been able to successfully create that file. Suppose that you've got a secure part of your system where only the kernel or only the root, the administrator can read and write files from that section. Should any arbitrary program be able to read and write files from that folder or that directory? No. So if for whatever reason, if your opening of that file fails and the creation of that file fails, it'll throw this exception here. This is a little bit different from C. If you're coming from a C background, you use defensive programming. You open up the file and then you check. Was that successful? Yes? Okay, move on. No? Okay, return an error code, right? In Python, however, this try catch will look familiar. Why? Because it's an exception. This is a modern programming way of doing error handling. I try some potentially dangerous code, and then it will catch me if I fall because it fails. It threw an exception. And then I can deal with it down here. Now, the auto-generated code here is just, okay, print a stack trace. For now, I'll leave that, and I'll show you a better way of handling that. Instead, let's go ahead and go back to what we're trying to do here, actually print out to the file. Let me run this. All right, no news is good news. Right? It was able to successfully create that file and print to it. But do you see that file over here in the data folder? Nope. Sometimes you got to kick it in the butt. Right? And to do that, I'm simply just going to tell it refresh. The quick key on that is F5 as well. Once you refresh, oh, okay, yeah, there is that file there, myoutput.txt. Right? You could close Eclipse entirely and open it back up, but why? Just tell it to refresh. Sometimes it's got to be kicked in the butt to remind it, hey, there are files on this system. Please go ahead and check for them. Changes. Right? Let me go ahead and open that up now. Hello, this is one line. This is one line with an out and end line. Now I'll put the end line character in, and there's the end line. There are the variables formatted in the default manner. Right? And then successfully close the file. If I didn't successfully close the file, what would happen? I don't know. Let's go ahead and get rid of that. It'll probably 99 times out of 100. Now the variables are, just to make sure that it's a change. Let's go ahead and run that. There we go. And, oh, what happened to all my data? Gone. All right. Hopefully, I've driven the point home. Close the damn file. All right. And by the way, what if I did this instead? What if I said demo.c or .c Java, right? And I'll close it. Right? What am I about to do? I'm about to open up myself, right? This source code right here. Before I do that, let me go ahead and put it under the clipboard, copy it, and let's see what happens. Let's go ahead and run this. There we go. And let's close this, close that, and let's open up the demo file. Oh, it did work. Okay, fine. Right? Probably because that's not in the same working directory. Because it's in what? Source, UNL, SOC. Now I'll go ahead and screw it up. There we go. And run this. Oh, here. Copy it and then run it. There we go. Close this and open it up again. Uh-oh. What did I just do? I lost my source file. If you're opening up an input file for reading, don't write to it. If you're opening up a file that you shouldn't be opening up, don't do that, right? So let me go ahead and restore what I had before, right? There are consequences if you screw this up, right? Hopefully on the grader, every year I forget to change it so that you can read only some of the files, and somebody inevitably opens up the input files, donks them by writing to them, and then I have to go back and fix it. Hopefully that won't happen again this year. But in any case, make sure that you are opening the proper file that you want to in the data folder. Make sure that you are closing it. My guess here is that there's a new demo.java file at the root of this if I refresh it. And indeed, there it is. There's my first attempt. Don't put source files where they shouldn't be. Let me go ahead and get rid of that. There. All right? Always close your resources. Close the file. All right? Let me go ahead and put this into the output or the notes so that you have it. Java. There we go. That's file output. Okay. File input is just as easy. Let me go ahead and. But are we going? Obviously, are we going to use a printer for file input? No, we're going to be reading from the file. And no, it's not read. It's not print reader or anything like that. Let me go ahead and change this to file out or file input. So I need to open up the file. First of all, I need to create the file that I want. And what I'm going to do is I'm going to start working with book data. Book data.csv. Right? CSV implies that it's going to be a comma-separated value file that I'm going to want to process. Right? Now that doesn't do any. Now, first of all, let me refresh it. Is there a book data.csv file over there? Nope. I don't see one, right? So how are you going to open it up for processing? Well, we'll find out here in a second. So I want to create what's called a scanner. s is equal to new scanner. All right. Now you might have used the scanner before. It is in the utility library, not the input-output library, because it's more general. The scanner can be used to scan the standard input, somebody mashing the keyboard, right? Prompt the user, please enter in a number, X. Okay, I'll go ahead and enter X. You can use scanner on system.in to do this. But I don't want to read from the system.in. I want to read from this file right here. So let me put it right there. Right? Now, whenever I do this, I like to say, okay, well, I'm opening the file. Eventually, I'm going to write to the file. What do you need to do? Close the file. So when I'm writing code, I will generally do that immediately, right? I will jump down a couple of lines so that I do not forget. Right? Once you've got the scanner open, you need to close it. And if I start writing this other part here, which is probably going to be way more complicated, I'm going to forget all about that down there. All right. I've got my scanner. We'll come back to why it's not compiling. The same reason as before. We're not surrounded with a try-catch. Otherwise, let's just go ahead and start reading from the file. I can go ahead and do a lot of stuff. F.next. Right? I can get the next string. I could get the next, it is really small, so sorry, but I can get the next Boolean. I can get the next byte. I can get the next double. I can get the next float. I can get the next integer, et cetera, et cetera. That's going to assume that your file is really, really, really well formatted, right? You have to go with that format exactly, okay? What I'm just going to do is I'm just going to open up the entire line. Give me the next line. Right? That will return a string called line. Give me the next line. So, and then then I'll print it out, right? System.out println line, right? Okay. Let me go ahead and just read in 3 lines here. Obviously, I can't have 3 variables named line, so I'll go ahead and get rid of that. And now I'm reusing that variable. I'm reading the first 3 lines of this file, and all I'm doing is printing them out. Let's try to get it to run. To do that, I'm going to have to do the same thing I did before. Surround everything with a try-catch. Right, and bring this up over here. There. At this point, I'm going to draw your attention to, well, what could you do? Right? Do you see this, what was it called, bookdata.csv file over here? Nope. So how could you reasonably recover from this exception? Right? Could you magically, out of the thin air, just create all that data? Probably not. So what I'm going to do is I'm going to do like some fishermen do, and I've caught my fish. Okay, great fish, right? But I don't know about you, but in Omaha, if you go fishing, they say, do not eat the fish, just throw them back, right? So I'm going to catch the fish. Why? Because of toxins and metals and stuff like that. So you caught your fish. What are you going to do? You're not going to eat it. What are you going to do? You're going to release it. You're going to throw it back. So I'm going to throw a new runtime exception, wrapping up that original exception E. Why? Because there's not really anything that I can do. What else could I do here? Create the file with random data. How valuable is that? Reprompt the user for the proper input. Well, that's assuming that you've got an interactive program where you said, please enter this file name, right? And the vast majority of programs are not like that, right? So is there really anything you can do? No. You just rethrow it and make it become fatal. It'll kill the entire program. Let me show you. Right, there we go. Lots of red there, right? There's a runtime exception, which involves a file not found exception because the data, book data, doesn't exist, okay? So let me go ahead and create that file then. New file, bookdata.csv. There we go. Now that file exists. By the way, it just opened it up in Excel. I don't like that. CSV files are plain text files, so let me go ahead and close that. And let me drag and drop it over here. If I just double click it, it'll just open it up in Excel again. So let me drag and drop it over here, and you can see the contents of the file. There's nothing, okay? Let me run that again. Now, am I going to be able to read 3 lines out of that file? Do you see 3 lines there? Nope. So let's go ahead and run it and see what happens. Uh-oh. No line found, right? That happened on line 30, right there. You can actually click on this stuff and it'll take you to the line that it happened on. Right? Well, it didn't get caught by this exception handling. Why? Well, because it threw a no such element exception, not a file not found exception. It found the file just fine. It's just that when you tried to go read the first line that didn't exist, it threw a different type of exception. If you want to, you can catch that exception, right? But you're not forced to, right? It compiles and runs just fine. Well, it doesn't run just fine, but it runs, right? You're not, some exceptions like file not found exception, you are forced to surround with a try catch. Those are called checked exceptions. And they were a mistake that was introduced into Java 20 years ago that we're still living with the headache today, right? It is a mistake that everybody learned their lesson from because no other programming language has ever done that since. And every single thing that has been added to Java later on has never used these checked exceptions before, right? Why? Because it takes control away from the programmer. We are forcing you to surround this with a try catch, right? Whether you want to or not. There's no way that we can recover from that. So I'm just going to head and throw it, right? Versus a no such element exception, I have the option of catching that. No such element exception. And you have to give it a different name, so NSEE, right? Why did I choose NSEE? No such element exception, right? And I'll just simply rethrow that as a runtime exception, right? Or I could do something else. System.out.println. Okay, no data in the file, ... Or moving on, ... Right? And I need to import this, I think, otherwise I'm misspelling. No, I spelled it correctly. Excellent. Right, there we go. Moving on, system.out.println. Okay, here's the rest of the program. Reset program. There we go. All right. Now let me show you that there's not going to be an error anymore. I mean, there kind of is, right? Oops, that I didn't, a colon. Weird. Okay, there we go. Now it compiles. There we go. Okay, no data in file. Moving on. In other words, I chose not to treat this as an error. I chose to treat this as, okay, there's no file data in the file. I'll move on with the rest of my stuff. If I were reading book data, then I would report no books found. Instead of what I want to report is, here's the best book, here's the worst book, here are all books by this particular author, et cetera, right? You can choose to surround things with a try catch, unless you are forced to do so because of some of these stupid exceptions from 20 years ago. Right? Again, it was a mistake. We've learned from that mistake. Right? Only C++ has ever added that feature, and they made it optional. And everybody just keeps it shut off because it's stupid. Right? All right, so now that we've got that, let's actually pull in some data. And I've got some data over here. Open with Atom. Let's go. Okay, and let me come over here to my CSV file there. There's a bunch. There's 100 books there. All right, I just pulled all my Goodreads data. I massaged it so that it looked a little bit nice, and then I winnowed it down to 100 so that it's more manageable. Okay. This is what a CSV file looks like. Here's a header. The first token is the ID. The second token is the title of the book. The third token is the last name of the author, first name of the author, ISBN, rating, and year. Let's go back over here to demo and process that. There are the first 3 lines, right? No error at all. Okay, there's no data in the file. That doesn't print anymore because there was an element that was found, right? And I read the first line, the second line, the third line. Right? Okay. All right. I want to read all of them. So I know that there are 100 books. So 1, 2, 3, 4, 5. Should I do that? No. Let's go back and rethink this. So I've got my new scanner here. What do I want to do? I want to read till the end of the line. Do you know how many lines? Well, we do, because I told you, right? There are 101 lines in this file. But is that always going to be the case? No. I don't know how many lines are in that file. So which kind of loop is most appropriate here to determine read this file from the beginning all the way to the end? A for loop or a while loop? A while loop. Why did you immediately go to a while loop? Because for loops are more appropriate when you know up front how many iterations you're going to go. Right? While s dot has next line. While you still have another line to read, read the line. Print it out. System.out.println line. Right? And this will go all the way to the end of the file. Monstrous Regiment by Terry Pratchett is the last book in that file. All right? Wonderful. Now I'm reading all this stuff. Now let's actually process the data. Once I read in one single line, for example, Monstrous Regiment, Terry Pratchett, comma, comma, whatever, right? Oh, there is no ISBN for that. So sometimes we have empty tokens. How should I process CSV data? How did we do it? So I've got the line. What do I want to split it up into these tokens. The ID, the title, etc., etc. What could I do? Split. Line.split, and I split on commas. Right? That returns a string tokens, an array of tokens. Right? Now what you can do is you can start giving them better values. For example, token sub 0 is equal to it's backwards. String book ID is equal to token sub 0. What's the second token? The title. Token sub 1, right? String author first name. I'll just say first name is equal. No, I'll go with author first name. Pratchett last name. Last name is equal to tokens sub 2, right? And by the way, those of you coming from a Python background are really going to miss the multiple assignment operation. It's not a real operation. It's a boxing and unboxing of a tuple. But what you could have done in Python is you could have done something like this: book ID, title, author, last name, and I won't do them all. But you could just go comma, comma, comma is equal to, and then you could unbox the tokens. You could have done this all in one line, right? Yeah, I kind of missed that too. Right? String, you don't have that in Java. First name is equal to tokens of 3. There is no auto code generation that can get away from this, by the way. You can do cut and paste. ISBN is 4. ISBN, what's next? There's the ISBN. There is the Goodreads rating. Is that a string though? Rating. 3.8, is that a, should I treat that as a string? Probably not. What should I treat that as? Double. Okay, I like that. And how do I take a string and translate it into a double? Double dot parse double, right? Undo parse double. Tokens of 5. Right, there we go. And finally, what's the year? Is the year a string? Not as I've got it right here. What is it? Int? Okay. Year. That's the publish year, the year that it came out. And to coerce a integer.parseInt tokens sub 6. And then I've got all those things and do whatever with this data. ... Before I was just printing it out. Let's go ahead and see if it works at least. Right? Uh-oh. Input string oops, sorry. Sorry. Yeah, okay, good. So number format exception. Right? What happened and where? So I could come down here and catch it and give some more information. Or I'm going to take this opportunity to fire up the debugger one more time. Come on. There we go. Let's go ahead and go into debug mode here. Right? And switch into my debug perspective. What's going on? So, step, okay, step. There's the line. The first line. Is that actual data? No, that's a header. So when I step, and I try to take the string rating and I try to parse it out as an actual double, that's what happens. Right? Right? It threw an exception. So let me stop this. And I'm going to demonstrate yet another nice tool of the debugger, right? You could have this could have happened somewhere deep in the data. For example, it could have happened on the last record of 10,000 records, or it could have happened on record 5,999 of 10,000 records. Are you going to step 10,000 times to try to get to that location? I don't like that. So let me go ahead and come over here to breakpoints and add an exception-based breakpoint. So add Java exception breakpoint. That's this button right here. It's an exclamation point because, warning, something happened. Let me go ahead and add it. Now, what kind of exception did we have? A number format exception. I'm going to add that. Now, that doesn't add it to a particular line. That adds it to an event. In the event that a number format exception happens, the entire program will pause and show you around. So let me go ahead and run this again. Debug mode. There we go. It stops on my first breakpoint here because I told it to stop at that line. Resume. And it automatically stops right there, and I can come over here and I can start taking a look at my variables. Oh, that's why a number format exception happened. The token that we were trying to read was rating. All right. Okay, fine. Where did that occur with respect to the lines, right? Let's see. Well, there's another stack frame there. Previously, nope. All right, so I'm going to have to come back up the stack trace. I forget how to do the stack trace, but in any case, you can at least see the variables here. And in this particular case, you're trying to parse out rating, right? So let's stop this. We already know what the problem is. Let's come back to our Java perspective. I suppose what you could do is come over to the data file and get rid of that header. You don't always have that option. Don't do that anyway, because that's part of the data. It's a header, right? So let's come over here, and what should we do instead? Let's just burn the first line. S.next line. Right? There we go. Or if you wanted to process it, you could. Right? I'm burning it in that I'm going to read it, but I'm not going to do anything with it. I read it and I throw it away. I'm not even going to store it in a variable. Now let's see if that fixes it. Okay, here's the rest of the program. It does. Right? You do have to be careful though still. Is there any data on any of those lines? Nope. So let's come over here and see what happens. Uh-oh. Array index out of bounds exception. What's going to happen when I get down to line 102? Can you read these 1, 2, 3, these 6 tokens or whatever, however many there are? Nope. So here we do need to do some defensive programming. You could use a try catch and then catch an array index out of bounds and then be on your way with the rest of the program if you wanted to. But what I'm going to do is I'm going to come up here and I'm going to say, okay, I've read the next line. I'm going to split out the tokens, and then I'm going to check if tokens.length is not equal to what I expect. Then I will issue an error message. I'll throw my own exception. Throw new runtime exception. Right? End of file maybe? Question mark. There we go. Right. There. I could do that. How many tokens am I expecting, by the way? 0 through 6. So that should be what? 7. Right. Now let's go ahead and run this. Okay. End of file maybe? Yeah, it's the end of the file. Right. So instead of throwing an exception here, what could we do? If it's equal to 7, then do all this stuff. Right? Otherwise, if it's not, then kind of ignore the line. Right? Else, do I need to put else? Ignore the line. Right? That's cruft. Right? Should you have empty else statements? No. Maybe at first on the first draft or something to remind yourself that, okay, if there aren't the correct number of tokens, then we're not going to do anything. But that doesn't belong in your final submission. Okay? Run this. There. Okay, here's the rest of the program. Did we ever actually do anything with that data, by the way? No. Let's come up here and say, all right, we want to know the best, or the high, I'm not even going to call it best. I'm going to say highest rated book. All these book ratings are from goodreads.com, right? What is the lowest rated book, right? What is the oldest book? Oldest book. I don't know, what else? What else would you want? What's the average rating, right? What are all the books by Terry Pratchett? 2 T's, I think. Yeah. So I want to answer those questions. Is this data in a form that I can start answering those questions, though? Probably not. I could take this rating and say, okay, save off that rating. That's the best one I've seen so far. And then also save off the book ID, the title ID, the best book, book ID, the best book title, the best book author last name, the best book. No, I'm not going to create 7 damn variables to keep track of the best book and update 7 variables to keep track of all of those. Right? Instead, what I'm going to do is I'm going to start defining my own objects. I need something to represent a book. Right? Gee, it'd be really nice if we had that built into Java, right? We have something to represent a string. We have something to represent a file. We have something to represent a scanner, right? Let's go ahead and create something to represent a book. A new class. What should I call it? This one ain't hard, right? In general, in computer science, there's a saying, there are only 2 difficult things. One of them is cache invalidation, and the second one is naming things. But sometimes it's easy. If I want to represent a book, what should I call it? Book. Should I call it books? No, it represents one book. Not if I had a list of books, then I would do that. All right. Should I call it book? And if you squint really hard and that's a lowercase b, should I do that? Remember the style guide that I just gave you. Capital B, book. All right. All right. Should I call it my books? My book? No, book. All right. Call it what it is. Right. Keep it simple. Right. Or KISS. Keep it simple. Sandy? There. Don't call yourself stupid. Right. That's the original acronym. Right. All right, I've got a book here. Right. Well, what represents a book? At least as far as our data is concerned, how do we represent a book? Those things right there. So I want those things to be over here. Right. All right, but that's not the syntax. ID, title, last name, author last name, author, first name, ISBN, and by the way, don't capital, even though it's an acronym, it's best not to do this. ISBN, ugly. All right, well, what if I followed a camel casing convention? ISBN, that's even worse, right? Just keep it ISBN. Right, keep it simple. Rating and year. There. So those are the things that are going to be in my object. Right? Most of those are strings. So let's go ahead and make them strings. Right? What's not a string, though? The rating. So I'll come back and say double. And what was the year? We determined that should be a integer. Okay. Now, it's still not going to work because I need semicolons at the end of everything. Come on. Semicolon, 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 semicolon. There we go. Right? Okay. Now I've got the beginning of of a class that represents a book. Okay. We've got a lot yet to go here. This is definitely not how you should design your objects. We'll talk about that later on. But now what I can do is I can come over here and I can create new books. Right? So I've got all those things. What I'll do is I'll say, actually up here, I'll create a book. B is equal to new book. Right? There. And now instead of saying just this variable, this local variable called book ID, what I'm going to do is I'm going to replace all of this with B dot. Right? And I didn't get them all. B dot. Because they weren't all aligned. Right? And it's not book ID. What was it? Actually, that's a good point. Should it be ID or should it be book ID? It's already a book. Good point. So should we repeat ourselves there? No. That's another principle. We've got the KISS principle. We've got the dry principle. Don't repeat yourself. Right? Don't copy paste the same code over and over again. Put it into a function. Don't copy and paste something 100 times to do a loop. Do a loop, right? And don't repeat things when you don't need to. It's already a book. We already have an ID. So I'm going to go ahead and change that to ID. Right? That's the beginning of a good class and class design. Well, if I want to store them all, I'm going to need something to store them in. A list is good. My books. Right? Note here, what did I do? I pluralized it, and I said that they were my books. If they were Goodreads, books, reads, books, right? And Goodreads is a website. I'll just go ahead and go with books, right? Is equal to new array list. There we go. And now down here, once I've created that book, do whatever with that data, I'm simply going to store it in that list. Books.add B. Right? There. Now instead of printing out, okay, here's the rest of the program, let's actually list out all of the books. Right? Yeah. Do those look like books to you? No. So one thing that I'm going to do really quick here is show you, you can add stuff. What I want to do is I want to say, let's print out the title of all the books. I could go into a regular old for loop here, for book B in the books. What I'll do is I'll system.out.println B. Okay? There. Well, that's only printing out the book, so I want the title. And that'll print out all the titles, one to a line. There we go. High Crusade, Soma Blues, The Wild Robot Protects, etc., etc., etc. Right? Now I'm getting all the titles. Okay? How do I do that with just a one-liner? Well, what I need to do is I need to go into the books and I say, when you print out this object, right, print only the title. Right now, what is it doing? Let me go back. What is it doing? What is that gobbledygook there? What is that nonsense? It's a memory address, right? And that's not what I want. That's the default. What I want to do is I want to create a public string to string method, right? And I'll return this .title. Right? In other words, I only want, when you convert this object to a string and return a string version of it, just return the title so that it looks something like this instead. The High Crusade, Soma Blues, etc., etc., etc. Right? You can get as sophisticated as you want in this function, and we'll come back and look at some tips and tricks here later on. But before I do, what I want to do is I want to find the best book. Right? We have enough time to do at least that. So what's the highest rated book? So not best, but highest rated book. Well, if you were to just do this normally, what would you do? You would create a rating, best rating. Right? I'll set that equal to -1 because all ratings are non-negative. And then I'll go through my regular old for loop here. For book B in the collection books, if B.rating is greater than the best rating, then I will update my best rating to be B.rating. Right? And then at the very end of this, I will system.out.println, what's the best rating? There. Right? 4.48, I wonder what that is. Right? Do I have enough information to determine that yet? All I have is what? Its rating, the rating of the best book. So let's go ahead and create another variable, book B, just muscle memory there, best book is equal to, I'll initially set this to null, but if I ever find the best book, better book rating, I'll go ahead and say best book is equal to B. And now I can output the best rating and the best book. So what, there, The Hate You Give, all right? That's a very good book, but that's the highest there? Cool, all right? Anyway, best rating, best book, all right? I did that in how many lines of code? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is there a better way of doing it? 10 lines of code to get the best book. And by the way, it's still not very satisfying because do I have enough information to say what the worst book is? Copy paste that stuff. What the average is, copy paste that stuff over and over and over again. Let's think about a little bit better solution. Right? If you were to take all of this data and reorganize it in a manner that would give you the best book, right? I want the best book to be here, right? Way at the top. What is that operation called? I think I heard it. Sort it, right? What if I sorted all of these books in descending order with respect to the rating? Where would the best book be? At the very top. Where would the worst book be? At the very bottom. Does that sound like a better solution? Yes, I agree. Right? Hopefully you agree. Right? So here's my outline. Sort the books with respect to rating. Right? Then the best book is the first, rating descending. Right? The best book is first. The worst book is last. Right? I could do this in 3 lines of code, right? That's much, much better. Except that, what do I have here? Sort. Collections.sort. Can I just sort books? Nope. Why? It doesn't know how to sort books. I have to tell it how to sort books. I don't have to tell it how to sort. I just have to tell it how to order books. That I want books in with respect to rating in descending order. Because there are other options. Right? You could sort books with respect to IDs in ascending, descending. With respect to title. With respect to authors. Their first name and then their last name. But what if I've got a bunch of authors with multiple books? Terry Pratchett has written dozens of books. How do you want to order those? Well, first of all, by last name, and then breaking ties by, I don't know, year, right? In chronological order, right? I've got a lot of options here, which is why it doesn't know how to do it, because there are 50 different options here. I need to program each one of those options, and then it'll take care of the sorting for me, right? So that'll open us up on Monday for searching and sorting techniques, especially with respect to user-defined types here. Okay? We'll continue there on Monday.